Hello and welcome everybody to our webinar today. The webinar is the next evolution of open source and the future of data. So let's just get into it. I guess we can go live with a video, Jess, if we're live. Okay. Hi everybody. My name is Jim Walker. I'm VP of Product Marketing here at Cockroach Labs. I'm joined by
Spencer Kimball. I'm one of the co-founders of Cockroach Labs and the CEO.
Yeah. So I guess in our between two ferns, am I Zach Galifianakis and you're the guest, I guess. Is that how it's going to work?
So I think so.
Cool. So we have a good set of topics to talk about. I wanted to start with a little bit of background on Spencer, but we're going to talk about open source to a good amount as well. It's one of our favorite topics to talk about. And then we're going to talk a little bit about databases and cloud and what we see 2025 and beyond starting to look at. So just to get things started, to give a little background, you, Peter, Ben, the three founders, were all at Google, right? Early days. What year did you join Google?
Oh, it was year 4 for Google.
Year 4.
It's arguable whether it was still really much of a startup then, but we were there for the better part of a decade,
right?
From 2002 to 2012, and worked on a variety of projects. Actually, one way I like to think of it is we kind of seesawed between building applications that used infrastructure,
right,
and then moving over and building infrastructure to enable the next generation of applications, and that process repeated itself a couple times.
I think I've been using something you built for like 20 years. I was originally at Google then. I used GIMP, so I think you and Peter built out GIMP too, right? That's so right. If people aren't familiar with that, it was a graphical photo manipulation tool. It was like everywhere. It is. It's still available.
Yeah, which is amazing because we stopped working on it in 1997. So it's the power of open source. It's still going strong.
But I think the back end, a lot of the stuff that you worked on at Google as well, even early days, all the way through your whole career there. What did you work on while you were at Google? You and Peter were together a lot of that time, right?
There was definitely significant overlap. Well, we did diverge in some cases. The same with Ben. Ben and I got started together actually on the AdWords project.
Right.
And we built all kinds of things. We wrote the Google Servlet engine, which was a replacement for Tomcat to kind of look more like Google, the way Google liked to run applications in production. We worked on an ORM for Google. We worked on their database sharding issues,
right,
which was a bit of a war room for several months of trying to make that thing scale appropriately. And then I moved over more into the straight infrastructure side, started working on distributed file storage, and that ended with about 5 years spent on a system called Colossus. Yep. Peter worked with me on that directly. Ben worked on Google Reader, so he kind of went the application route at that point. Pete worked on some computer vision stuff at some point, so we kind of all over the map, but we got a nice sampling for both the kinds of opportunities in terms of what kind of applications you could build, and the challenges, which often, in Google's case at least, were an opportunity to really invest in R&D and solve a problem in a new way using the fairly unique at the time combination of users everywhere around the world,
right,
and incredible ability to distribute a new application to those users because of the power of Google's platform, but also Google's incredible investment in their sort of private cloud infrastructure, which of course has been extended into GCP in the modern era. But that was in the aughts quite an incredible thing to have as your reality, a data center in every region, in many cases multiple data centers. What kind of new infrastructure could you build when that was your reality? And the answer was quite a bit. Google was willing to invest in it.
Right. I always joke that, Google builds new things because they can hire a bunch of really great engineers. It's like, yeah, why did they have to rebuild Tomcat? Well, it's not because they had to hire, it's because they actually had a different vision of what this stuff was, right? And so, what were some of the things that were behind, Colossus and the build out of a file system, that had to scale globally? That was important, early days at Google.
There are a couple things, but it all had to do with scale.
Yeah.
And previously, Google's first attempt at this was something called GFS, which is the Google File System.
Right.
And Colossus was the successor. And the reason for Colossus, there were two big ones. One was they needed to make clusters that were 10 times larger, or even maybe 100 times larger than the biggest they could do with the architecture that GFS was built with. It's kind of like these architectures, they do really well for a certain number of years, and then they start to get a little bit long in the tooth.
Right.
Google's solution wasn't to keep trying to upgrade the same one with all the legacy code paths and all of the bells and whistles and things that had evolved over the years. Their solution was, you know what, we're going to redesign this from scratch with something that doesn't have any of the bells and whistles. We're going to do it for just a single use case, and then we're going to expand it a little bit to get the next use case. Then we're going to expand it a little bit more and hopefully get the next 4 use cases, then a little bit more and get the next 20 use cases.
Right.
And then they'd eventually move everyone over, and then they sunset GFS. And that took years to happen, but it's mostly about scale. And then the other big thing, which comes with scale, is how do you save money?
Right.
Because Google was shoveling truckfuls of cash, and continue to, of course. And the question is, can you shovel half truckfuls of cash? And the answer is yes. Interestingly, with distributed file storage, there was some things that Google definitely didn't invent, but were well known, called ReedSolomon codes that would decrease the amount of replication necessary in order to store data with the same level of the same guarantees around availability.
Right.
And it's just really interesting trade-offs in the space, but that was one of the big things that was different about Colossus. It cut the effective cost of storage from 3x down to about 1.666 repeating.
Right. Yeah, I mean, fast forward today, and a lot of what they learned early days, right, and kind of you being on the front lines of that, is a lot of stuff that's being applied today. And I think the move to the cloud is because of this, the reduction in operating expense, right? Like, and you have to go through these efficiencies to actually make that happen. I think, you know, you talk about how they invented tools, or they iterated on tools as well to kind of accomplish things. You know, they also had BigTable. And I think that's now like consumer grade, right? Like we see people use that all the time. It's fantastic, right? What about from a relational data point of view? I think you were there kind of watching what happened as well. And then after Google as well, you witnessed some of this, right?
Yeah, you know, when I started Google, as I mentioned, I was on the AdWords project, and the AdWords had opted to use MySQL. And the first version, I'm sure, ran on one MySQL database. And then that started getting too large. And so they said, okay, we're going to shard, and we'll put some customers on shard 1 and some on shard 2. And the application will know based on the customer ID, which of those databases to talk to. Then it went to 4 shards, and then it went to 8 shards. That's where things started really running into all kinds of technical problems. And eventually that system, long after I had stopped working on it, had gone to 1,000 shards. But long before that happened, and it did get replaced at that point with Spanner, but long before that happened, the sharding of MySQL at the application layer became, I'd say, an anti-pattern within Google.
Yeah.
So it was, I wouldn't say outlawed, because other things did, you know, follow suit, especially in the acquisitions that Google made over the years. But Google decided this is a solution that we don't want to embrace. We don't want this to be ubiquitous at Google. And instead, how do we build new kinds of databases? And you mentioned relational. I think in the early days, Google decided that, you know, relational just was too difficult to do, and also accomplish what they wanted to accomplish, or maybe needed to accomplish,
right, yeah,
in terms of just massive scalability of the systems.
Yeah.
So BigTable was the first real read-write style database.
What year was BigTable? That was
came out. It was, the paper was in 2004,
yeah,
I believe, but of course it was under development quite a bit earlier than that. Made it into production earlier than that. You know, BigTable was, you know, I think most people would cite it as being the advent of NoSQL.
It really is.
And
yeah.
I think the really important thing to realize, at least from Google's perspective, is NoSQL wasn't created because people didn't like SQL necessarily. It was created because SQL and elastic scalability were too much to implement together. And so you got to choose one or the other. SQL wasn't, you know, many of those use cases that BigTable was initially applied towards, you know, they had simplifying assumptions.
Right.
But we don't really need to have transactions, and we certainly don't need this relational querying capability. So we can simplify those things, get the scale and the replication and so forth that we're looking for. But interestingly, this isn't, I don't think, so widely known. It only took about 2 years for Google to realize internally that they didn't want to build applications directly on BigTable, at least not general purpose applications.
It's interesting.
They decided there wasn't enough transactionality in BigTable. They introduced something called Megastore, which only took about 2 years. I remember there was like a kind of a push when BigTable came out because it was really cool and it won the, I can't remember where the paper was submitted, but it was a big deal, just like GFS was before it, because it was so innovative. And there was a push to do more at Google on BigTable, and including towards the AdWords team that had been using MySQL. And by then the AdWords schema was probably 150 tables and obviously needed to be transactional.
I'm still stuck with you saying that AdWords was on a single shard of MySQL.
Oh, one day it was.
I know, like, it's
when there was one user.
It's just awesome, right?
Yeah.
Like, I'm sorry, but
yeah, it got quite a bit bigger.
Yeah, exactly.
But, yeah, I mean the response for the MySQL, teams, or at least the AdWords team using MySQL, was BigTable is great, super cool, but there's no way we can move this model to it. It doesn't have transactions, doesn't have a notion of these schemes. Everything's really hand rolled, and we could potentially do it, but the amount of work necessary, it's not an appropriate solution. So that led not for AdWords directly, but for other kinds of projects that were increasingly cropping up at Google towards new architectures and new capabilities added to the BigTable ideas. And that's where Megastore came from. And then only several years, or maybe just 1 year after Megastore really kind of hit production, that's when the planning for Spanner started.
Right. Cool. So I want to go back to something that you said. It was actually kind of interesting. And it actually works really well with this transition of Google from early days MySQL all the way through to kind of fully distributed SQL with Spanner. That took years. It took years for them to go through that. I think, I don't know, I'm enjoying watching what Kubernetes is doing to a lot of these organizations today. And like, I think I feel like we're really going through this kind of radical paradigm shift. Like there's this massive transformation that's happening within all of IT. I think there's lessons to be learned about, like this paradigm shift like Google went through. I mean, I know Brandon Phillips, one of the founders of CoreOS, used to say Giphy, that was one of his big things, like Google infrastructure for everybody. Which actually, fast forward, it's kind of happening, right? But
how much after the fact? I mean, it's important to keep in mind that it was definitely Borg, which is the Google homegrown predecessor to Kubernetes, was at a level of fairly advanced sophistication by 2005. And Kubernetes, I still don't believe, I mean, in some respects, I'm sure, but overall isn't quite at the level of sophistication that Borg had that early.
Right.
So it's incredible the interval of time before Kubernetes is becoming as widespread as it is, to when its predecessor, which was in many ways more capable than it even today in 2020, was fully fleshed out back in 2005, 2006.
Is that just the maturity of the tech, or is it maturity of the company, Spencer? Right? Like, because I think, if I look at Google is able to hire 10,000 people to go the last mile. And I think we're trying to apply something that's very general purpose to a very broad, set of customers with various different needs. I mean, every company is very different, as you know, right? Like, you consider that to be the issue, or is it just that, Kubernetes is a different, code base?
I think you bring up a really good point, and it's a unbelievable double-edged sword at Google, right? Yes, they have a tremendously, pedigreed set of engineers at Google, and the bar to work there is quite high, and you expect those kinds of engineers to be the ones that can read the source code and figure things out for themselves where they run into a problem, and they do, believe me. Like an engineer not related to something like Borg would go in there and modify and send out a pull request all the time.
Right.
And that was what you would expect from your customers. And so Borg, of course, grew and evolved very quickly in that sort of an environment. And so that's the nice sort of cutting edge of the sword that cuts away from you at Google. Where it actually ends up cutting them is that they often then take those solutions, try to polish them, put them into their cloud, and then leave much of the broader public ecosystem with a solution that there's a big impedance mismatch, right? Either it's too complex, it has non-standard APIs, and Google's unaware of this, and they progressively seem to get better as they iterate and put things into the cloud. But it's their blessing and their curse that the customers for all of this infrastructure and the first iterations are internal to Google. And then when they try to go external, there's a big bridge to cross.
I've joked about this for years. It's like when I first started using Google Slides, I'm a marketer now, I don't code anymore, right? But like, it took me forever to actually like Google my mind or something. Cause like I had to think differently, right? And like all their products are really good. And it's like that last 10%, you kind of got to manually start to do things. And I think that that's kind of been one of these things. I think that's happening with Kubernetes, but I think Kubernetes also has a very rich and complete and activated, that's for sure, open source community built around it, right? And so let's just shift a little bit. One of my favorite topics to talk to you about is open source. I think open source it's a hot topic these days, right? What do you think is, why is that, right? Like I think, I won't seed it. I'll leave it as open as that, and we kind of see where we go. But why is
you're asking me these questions because I feel like you know more about open source.
No, I don't. I just love it. I love it. It's a great topic, right?
It is a great topic, and people are very interested in it for good reasons. Yeah. And I think the biggest one is just the consumption model, and I think that's what just rocketed open source into the dominant software paradigm.
Right.
And the reason is, there's a strain of open source thought that's, very principled and idealistic, exemplified by someone like Richard Stallman and the GNU projects. And I'm sympathetic to that, but I think what really launched open source into the mainstream was the fact that previous to open source, a developer wanting to use software had to go through procurement, right? Which is an incredibly painful process. You have to get budget. You have to work with the sales folks from whatever the vendor is. The information about that software was difficult at best. You might have to read a review in a particular journal or something like that in order to.
And even if you didn't go through procurement, it wasn't approved, right? Like the early days of Linux, people would try to use it. And it was like, no, you couldn't put that into production. Like it was to safeguard the company, right? And so the procurement was there to like safeguard them, but still.
And the knowledge of how to use the software that was closed source was often limited to a set of printed, stacked up manuals. If you were lucky, if there was even that much information, you couldn't consult the source, of course. So getting started with it was a very slow process. So if you just think about what's the time to value from when you conceive of an idea to when you can get the proper, infrastructure, or tools, or libraries, or whatever you needed to build it. And the answer is that was necessarily going to take months in the closed source world. Now with open source, developers can just download something, play around with it for a matter of days, get it running, start to integrate with it, test with it, and so forth. And the cost of that was very low from partly supported by the community, which was different. All of a sudden, you could look online and get answers from a whole bunch of other people. The cost in terms of, what kind of outlay or budget was necessary went to zero, which is unbelievably incredible. And it's just that time was compressed because you just didn't have to go through this lengthy process. And so you could actually stand something up as a startup or as a small team within a much bigger company overnight. Yeah. And that was the catalyst for business value. And that's why, open source moved out of the sort of academic, Unix focused environment into like truly the dominant paradigm.
Yeah. And I've seen this consumption thing go through various different iterations as well. Like to me, the beauty of open source has always been consumption. Like, but you know what I didn't like to do was download binaries and compile them and deal with make files. And I hated it. The fact that I could actually package these things up into a VM and then just have a VM, like that was a massive, huge leap forward, right? And I remember, 2009, that's the way we were distributing then open source packages, right? Because you didn't have to actually go into it. You still had code, you still had a community of people, but that changed. I think the consumption model has continued to change, right? Yes. And so I think with the advent of software as a service, there's massive, huge transformation as well, right?
Yeah. That's a good point you made. I hadn't really thought about that, but you're right. That was definitely an intermediate stepping stone. And all of the pre-built packages and binaries and so forth that you could simply download and that were vetted and tested by the community. That was a great stepping stone. But you're right. Things have changed again, and they've changed dramatically because just like the change from having to go through procurement to being able to simply download almost instantly from online and use, this time to value is further compressed dramatically. Right. And it's not just, how long does it take me to, as a developer, start to use this and integrate with it? If it's a service that's being provided, say, in AWS, it's much more about day 2 operations, right? And what's going to happen when we actually launch? Do we have to understand how to monitor this? What are the failure characteristics of this particular piece of open source software in our stack? And now you can use something like RDS and AWS, and now you can have a MySQL or Postgres database, and you don't have to do anything with it except for program towards it. And that is another fundamental step forward. And you can see how it's affecting a lot of the commercial models that have been built around open source. It's making an end run around them, because if something can be offered as a service, on a platform, and we're seeing this with Amazon AWS, it's a very good way to essentially win the market, to get every developer out there or operator to use your service.
Yeah, and I think that's what's hot in open source these days. I mean, like it's been the last couple of years in terms of what's happening with open source projects as they kind of butt up against these large public cloud providers and being able to distribute things as a service. It's just like, I always think of open source as like, there's the 4 things, right? There's code, I can still check out the code. There's community, and I think a good open source company builds a community around them, but then also by giving your code to the community, you show people how to actually do things, right? It's really intelligent stuff in there. This consumption thing is where it gets really interesting, but we're like overlaps with cost. I like alliteration, so you know me, dude. So the business license and the licensing around open source is, I think, where people have had a lot of discussion recently. Over the last year. We went through our license change. It was about, and time flies, 8 months, right? Something like this. What was our thinking, and what was the thinking that we went through as a team here internally to shift to the BSL license? And what is the BSL license?
A lot of questions there.
I know.
Well, so we do believe strongly in open source. But when we started Cockroach, it's always been a commercial enterprise, and we wouldn't be able to build the database we built if we hadn't been able to get the investment. So it's a very big project to build this kind of piece of infrastructure software. So what's happened over the last year in particular, but certainly it's been evolving for the last 3 or 4, is this very nascent open core model that was pioneered by, I think MySQL, did they have enterprise features? It might go that far back, but certainly companies that are more recent, like Elastic, is a great example of a company that did a good job with an open core model. That has increasingly been under attack. And the reason is because, the premise of the open core model is we'll have a very powerful core, which is open source, and then we'll put value on enterprise features in a constellation around it, where we can give startups and people that just want to play around all the power of the open source, and they can make huge amounts of progress there. A bigger company that wants to use that open source is going to want not just support and indemnification, but additional features that really make sense in an enterprise environment.
LDAP and
Exactly.
Certain integrations, absolutely.
And so what we've seen though is that the expectation was that the really big companies that own the platforms like AWS and Google and Microsoft wouldn't deign to compete directly with those open core companies on their enterprise features. They might provide the core that's open source, and that's just good competition, in my opinion. That is completely allowed by open source, and I believe it was very much contemplated by the companies. Which is, think of, if you're Elastic, you might say, okay, well, Amazon can compete with us because they're just going to use our core, and we can get the big enterprises that are moving onto the cloud because we have all these offerings that you really do need as a big company. Amazon can keep selling just the core. We can outcompete them. What Amazon has or AWS has done more recently is they said, those enterprise features that you were holding in reserve, we're going to re-implement them ourselves. And we'll make those open source in a different forked, version of the core.
Exactly. We're seeing it all over the place. Lots of different projects.
And there's nothing wrong with that. There's no right or wrong in this, and it's perfectly legal according to the licenses. And it makes sense from Amazon's values perspective, which is,
go on, sorry.
It's just obsess about the customer, right?
Exactly.
It's like, Can they provide a cheaper alternative that's just as good as what Elastic's providing? Yeah, they can take the core and they can re-implement these things, and then they can provide something that's going to, be a cheaper alternative for their customers. Totally makes sense, right? But it also puts a huge amount of pressure on a company like Elastic or a company like Cockroach Labs that's depending on that model not being competed with on enterprise features, and that was baked into how you approach the model. And the problem is, of course, that Amazon has an incredible platform from which to compete.
Yeah, exactly.
Right? They have the kind of like Microsoft Windows, and how Microsoft was able to use that platform to their advantage to beat WordPerfect, as an example, with Microsoft Word, which was by most accounts an inferior product, but because of their platform advantage, they were able to make it ubiquitous and fundamentally to drive WordPerfect out of business.
And I always say that, the platform point of view for them is they've made it really easy to adopt software, like really, really simple, right? It's a few clicks and you're there. Okay, there's probably a complicated pricing model, but you know what I mean? I think that's what they've done. And I think we've realized ourselves, like actually building a database is one thing, building something as a service is a wholly other function, right? And I think you have to build that muscle as well, right? And I think they've done a good job, right?
Yeah. AWS is definitely the world leader in services, and certainly databases as a service. They have more customers, database customers, than any other company in the world, including Oracle. They don't make as much revenue as Oracle does on it, at least not yet.
Volume, sure.
Yeah, volume. In terms of just sheer logo count, they're I think well in the lead, and that's incredibly impressive. I don't think anyone does services as well as Amazon does.
Yeah.
But what does that mean for a company like Cockroach Labs?
Exactly.
And we would like to continue to be in business, that we continue to make this database as live up to its potential.
Yeah.
So that's where we brought in the BSL. And the way the BSL works is business source license. It was originally created by MariaDB.
Mm-hmm.
And it has two components to it. One is a period of exclusion, and the other one is the sort of items that are being excluded, exclusionary clause. So what that means is, the right way to think of it is, for some period, you're going to protect your, in our case, our core database product. It's kind of like a patent protection. We set that term at 3 years. Yeah. It's kind of enough in software that's moving very quickly that it's a pretty big disadvantage to use a version from 3 years ago, for example, versus the most recent one. And then what do we protect in those 3 years? That's the other piece of this. And for our case, it's very little that we protect.
Right.
Like our BSL has only one exclusion, which is that you can't run the core the core database as a service for external users. So it's really, it's preserving for us one bit of exclusionary competitive usage. One way to think of it, it's a little inflammatory, but I think it does make sense. It's kind of like the anti-AWS clause. There's the AWS exclusionary clause, because most people aren't going to, contemplate taking something like Cockroach and creating their own RDS for it. But obviously, it's a huge risk when you look at Amazon's past behavior.
Right.
So what happens after that 3 years is that the software becomes Apache licensed. So if we released a version, this month, then in February of 2023, that version would become Apache. So, you can see what happens is there's this legacy of open source, pure open source that's left. In the meantime, what's BSL and protected for those 3 years is not strictly open source, but it's exactly the same with one exclusion. Right. And that one exclusion is that you can't compete by creating as a service. It's worth pointing out that you could take that core, you could make it shrink wrap software, you can provide support for it, you can resell it. It's essentially equivalent. You can still fork this code, you can debug it, you can make changes to it and submit those back. You can do all those things. You simply can't, for 3 years, use that piece of software to create competing database as a service.
And it's really important to call it that. Like, that's the one exclusion. Everything else about open source, in terms of you can inspect the code, you have availability, you can go look at our repo today and look at all the incredible stuff that the team has built. Our contribution,
the ideas being free, that part of open source is preserved, and it is important when people think of the term open source to realize that it's a conflation of many different desirable properties. and when you break those desirable properties down and enumerate them, you realize, well, actually there are distinct versions of what a lot of people might consider to still be open source that wouldn't be strictly open source according to like the OSI definition.
Right. And that's okay too. Like community is a big piece of that. I have a lot of conversations about this with people because I believe that a company can be open source without even having open source software in many ways, because I think it's an ethos as well, right? Like contributing back to the community. Some of the stuff like Nathan and the team have done around, or not, I'm totally, Tobias has done around, contributing back to etcd.
Mm-hmm.
And this sort of stuff, like giving back so that other companies that are going to use these open source projects will never run into problems, and being upfront and forward about that. I want to go back, and this is kind of a good segue into the next section. I think, we agree on open source. There's also this 3-year thing that we were talking about, right? In a license and consumption, the 3 years. The topic of this webinar is, what's the future of data? So if we were to fast forward, right? If somebody did take our stuff and want to compete with us 3 years from now, let's go to 2025, right? Let's just push it out a little bit further. And so what do you think the future of database technology needs to be? I mean, we've come a long way with databases over, since 1971, I think IBM did the first, whatever that thing is, right?
So the Sabre reservation
exactly,
system.
right?
It wasn't the first use of a database,
exactly.
But yeah, it was definitely.
We've come a long way, but I mean, I think we're going through this kind of paradigm shift right now. We talked a lot about stuff that, like, I think broadly, like this move to the cloud, just systems in general, there's a whole new stack of stuff, and the database is changing too, right? So what do you see as, the 2025 or the 2026 data? I hate saying those words. This feels like I'm in like Star Trek or something. It's 2025, dude. So
yeah, it's not
that far away, actually. So
it's going to happen before we know it.
Yeah.
I mean, a lot of it's just going to be a maturation of the trends that are already evident. In fact, have been evident since, a decade ago when I was at Google, which is, databases fundamentally have an opportunity to expand, to use the resources that the public cloud provides. So, what does that mean? Well, certainly within a data center, you'd like to be able to add commodity hardware to a database, and it should just get bigger. It shouldn't be something where you're manually sharding and having your application direct to different databases. That's a very sort of primitive way to scale databases. Further, you should be able to contemplate, okay, we actually can use in the public cloud multiple availability zones.
Right.
So let's replicate across actual data centers, and that will give us less correlated failure domains. Right. So that's a way to just enhance resilience in a database. And then, looking even further afield, it's this realization that latency is starting to matter more and more. And you can't get good latency for a user in Australia if they have to hop all the way to Virginia in order to hit the microservices, talk to the database, come back out, and then go all the way back to the user in Australia. In fact, you can't do that in less than several hundred milliseconds. And that doesn't feel right if you're in
goes back to the 100 millisecond thing, right? Yeah.
Right. So the 100 millisecond rule, which is pretty interesting. It was, at least the first I've seen mention of it was in the Department of Defense. They did a study on command and control systems. What's the maximum latency from a user making some sort of action to when that action has an effect that's visible,
right? Like
hitting a key on your keyboard. When should you guarantee that a letter appears on the screen? And that's 100 milliseconds. And when you go beyond that, you've introduced a delay that's perceptible to a human being.
Interesting.
And that can befuddle the experience of what should feel instantaneous and non-virtual.
Right. And in these geographically dispersed systems, it's a big deal, right?
Yeah, absolutely.
From a database point of view.
You've got this speed of light problems. It's not even the speed of light through vacuum. It's through lots of communication networks with plenty of delays and not a great circle around the planet either. So there's significant latency right now in virtually all use cases. If you're thinking about trying to serve a global audience, and you've deployed your application the way virtually every application is deployed, which is in a single availability zone primarily. And so everyone's going to this one place on the planet. And that is the old model. And what I'm expecting to happen by 2025 with databases and data in general and building applications is really this idea of building a global application. So what does that mean? It's a global application. I think
Hey, that's a great question.
Yes.
What's a global application?
I mean, fundamentally, you just need to look at the companies that have built them.
Yeah.
Right? Google, Facebook, Netflix.
Yeah, that's another big one.
Apple.
HBO for that matter. I mean, they're streaming everywhere. Like there's huge, massive companies doing this cool stuff. Yeah.
So, those kinds of companies have figured out usually, and this is not an exaggeration, with engineering centuries or engineering millennia, in terms of just how many actual hours engineers have spent building these kinds of data architectures. They have created what amounts to global applications. And what that means, if you want to boil it down, is can your global customer base, wherever they are, have what feels like a local experience?
Right.
Like, are they close enough to a data center that has the ability to execute their common use case in 100 milliseconds or less end to end? Right now, it's not uncommon when you're clicking on your mobile device to wait seconds, right before something happens that you're expecting to happen. And we're used to that. But I'm sure you've had this experience many times, but if you're on a train or you're walking through a very busy street on Manhattan where people probably should be paying attention, everyone is looking at their phone. Every single person is interfacing through this little screen into some kind of virtual world, whatever it is, right? It could be a productivity app. They could be on Slack. They could be.
That never happens to me when I'm trying to get on the subway. Never, ever, ever.
I get bumped by a lot of people that are deep in that world, right?
In mode.
So that's the huge opportunity, right? Because the amount of time that an average person now spends in these virtual realities with a very unrealistic experience between a cause like hitting a button and the expected effect is a huge, it's an opportunity, an unbelievable opportunity that's ripe for the whole next generation. I mean, people always wonder what's going to happen, what's going to be the big next platform shift, right? Because we had the iPhone and that was so obvious in hindsight. Of course, it's just going to spawn this amazing re-platforming effort as everyone moves, every new use case is reimagined for what this new platform feels like. And I think that people are always wondering, well, what's the next one going to be? Is it going to be an Apple Watch?
Right.
No, right? Obviously not. But in hindsight, obviously,
wasn't so obvious.
Yeah, no, like it. But it's not.
I like it.
It's not the gold rush, right?
That, I'm Dick Tracy messages. It's cool,
Yeah, I think though that 5G, even though it's just another increment in the number in front of the G, is actually representing a potential for a new, what feels like a new platform, a new gold rush. Like, can you reimagine every app? Can you reimagine Facebook for how it's going to feel, or Twitter, when you're able to interact with something in far closer to real time or in real time, so you can see what is this tweet, what is the effect of this Instagram post in terms of like the real time, how people are interacting with it, what their reactions are. You could have that same experience if you're in a crowded room and you're the person that's speaking. You're able to see all these different reactions. Right. There's all these subtle clues, like how is my message actually being perceived? That kind of thing is going to change the those subtle sort of clues can be built into these platforms in terms of how this next generation of user experience as you're interacting with your phone, which is what people spend half their waking hours doing, maybe more. Right.
Yeah, it's funny. It's like we were talking about this before as well. It's kind of like the last time we saw such a shift in speed was when we went from dial-up to DSL.
Yeah.
I mean, and if anybody was around at that time, like it was awesome. It was the most amazing thing that had ever happened. And I think the apps that came out of that were just tremendous too, right? I think that's when we started getting, interactive, applications that people actually, they became a reality. And so we're kind of going through that same thing again, right? And it's
you kind of went from the text-based multi-user dungeon to like, Fortnite. Right?
Exactly. And we're at Fortnite now. So like, there's going to be something beyond this, right? And I think right now, and at least in my opinion, 5G is a bunch of commercials from like Verizon and whoever, they have the best 5G network. I don't think people realize what this means, the advent of, like you just said, like the move, it's an incremental number, 4 to 5 seems very small, but it's a huge, massive leap.
It's an incredible leap. Yeah. It's rare in telecommunication networks to have a drop in latency like the one that's expected here. And that can have, tremendous impact in terms of, how people can reimagine what today are the, multi-billion-dollar, user platforms, like,
Right.
whatever, there's some sort of social aspects to them, or they're gaming or whatever. All of those are ripe for reimagination,
right,
in a world where 5G becomes the normal standard, which will happen by 2025. And so the question is, how do you make it so that the next amazing idea for a multi-user game or AR or VR experience, right, or something like that, how do you make it so those developers can build with a new ecosystem of infrastructure and tooling,
right,
can build a data architecture out of the box as a startup that looks like something that Facebook has spent engineering millennia,
right,
building over the course of their history, and obviously very painfully replatforming, and it's not easy to do that, right? But can we bring that all those ideas, boil them down into general purpose systems to enable the next generation to build things that were previously difficult to conceive?
So are we going through basically a massive shift in some of these? We've seen a lot of, web scale companies come out. I remember Web 2.0 came out. It was like, oh, there's web scale companies. Are we going to see this like the next 5G scale? Is that, are we looking at, is this just another, where everybody, Uber's going to get Ubered?
Absolutely. Will Uber get Ubered? It's kind of question, would Facebook get Facebook? And you have these network effects, which can be hard to overturn, certainly, but not impossible. I think what will more likely happen is it's not just going to be a strict reimagining of the same paradigm, but a new take on the old model that is sufficiently different that people are interested in it. And it is very clear to me, looking at some of the newer startups out there that are using Cockroach, that where those startups are currently being run by or employing ex-Google, ex-Uber, ex-Facebook engineers, those engineers are coming to the next project with a very different attitude than they had when they joined Google or Facebook or Uber, right? And when they joined those companies 10 years ago, or whatever it was, those all were launched in a single location, right? And then successively and iteratively were expanded to become the global applications they are today. Right. Now, when these engineers are starting their next projects, they're saying, okay, we want to obviously build for this global audience. Like, why would we build for something that's only going to work well on the East Coast of the United States? Right. We fundamentally realize that our ambitions include users in Brazil, and users in Turkey, and users, absolutely. Yeah. So we are not going to start with something that's just going to have to be replatformed again and again and again to get us to where we were, where we saw Uber go, for example. Yeah, I think it's a really good point to wrap. It's kind of like, look at those engineers have been through the paradigm shift. They get it. They understand the distributed systems and what that means. And if you wrap it back, I want to answer your question, what's a global application, a little bit? Because I think global means scale. I think we started this conversation talking about Google and the scale, but I think, it's scale, it's resilience, it's being able to give an experience to people no matter where they're at, addressing that latency thing, right? And so I think that's where we're at today with Cockroach, with CockroachDB and Cockroach Cloud, and people can do this. What do you see the role of Cockroach, over the next, for the developer, over the next 3 years? Because I think, we've created something that I think is pretty easy to get going with, It is. To get up and running with Cockroach Cloud. So primarily we created something that was easy to get going with if you wanted to run the database yourself. Exactly, yeah. And that's had a lot of great knock-on effects for us. It's very easy to deploy Cockroach in lots of different environments. Right. But, to our earlier conversation, it seems that the future is going to be won by services. And so obviously we've been building Cockroach Cloud for the last year, which significantly addresses this. But there's an opportunity to really push the consumption model of how users use relational databases. Right. And it's going to go hand in hand with how do we make it so that the next cohort of amazing companies that come out of startups, how are they able to efficiently use this new infrastructure like CockroachDB in order to build the next generation of applications and services. Right. And this sort of also ties together our conversation about open source, so that you can see all these things are converging.
It all comes together.
Like, what does open source mean for us by 2025? I mean, to my mind, it's obviously the source is available because you want those ideas to be there. You want people to be able to debug and to augment the code as it exists. You want to have community for obvious reasons, and that's not something that has to be lost here. Consumption is the big one that's changing. Right? It went from downloading the source and compiling yourself to downloading the packages and the binaries to now just consuming the products of the open source as a service. It's just that much faster. What's kind of missing is that fourth C, right? You have code, community, consumption, and cost. Because right now, in order to have the consumption model of the online service or the cloud service, you always pay for it.
Right.
Well, not always, but in infrastructure, virtually always, right? And that's what I would like to see change. The reality is that should be free as well. You should be able to. You should be able to consume a relational database as a developer perpetually for free as a service. And that's really going to restore the balance to open source. Because if you think about what Amazon's been doing, they've been taking open source and they've been monetizing it for everybody, right? Because nobody wants to run these things themselves anymore if you kind of look at the horizon. And as Amazon's saying, well, we'll close source things, no problem. If we have to build it ourselves, we're definitely not going to open source it. Why would we waste our time doing that, right? But we're going to take this open source, we're going to augment it a little bit, integrate it, and provide it as a service, and we're going to charge you for it. We're going to charge everyone for it because we can, right? Well, that's what needs to be disrupted right now. Which is that we want to have things that really are available, all the source code, all the ideas, and to have the new consumption model of being able to run it as a service in the cloud without having to understand what day two operations look like ever, right? But also making that free, perpetually free. So every hobby project, right? Every hackathon, every bit of academic coursework, you should never have to think, okay, if I want to run this little thing and keep it running, I have to pay $50 a month to RDS. Right? No, this should just be free. There's no reason that it shouldn't be, and it can be.
So going back to the free beer.
Free beer, yeah.
Right? Like go and get the software.
People underestimate because it's always like, oh, there's free beer and then there's the free ideas. But
there's free puppy too, remember?
Yeah, well, free
and
beer.
And that was the consumption thing, right? And so like, this is basically bringing those two things. Like, it's like you can bring software to people and give it for free, yet still allow them to consume it as a service is what you're saying, right?
Yeah, and that's also a certain amount of freedom, right? It frees you from the yoke of having to really understand how the software operates and what its failure modes are, and to monitor it, and to alert on it and so forth, and to own the pager for it, which is incredibly expensive. So, the
free puppy part. Sorry,
yeah. So that consumption model is a certain amount of freedom. All of it is about freedom to a certain extent. Yeah. But the free beer, never underestimate how important that is to a developer.
I don't.
I don't like 30-day teasers.
No.
I want something. I think the analogy that resonates best with me is, what did email look like in 2003? Mm-hmm. You had Hotmail and Yahoo Mail and AOL Mail. Do people really use those anymore?
Well,
maybe your mom.
There's some people in my family that I just let them watch it and they're gonna laugh. But yeah,
well, there's
a couple of Yahoo users out there.
Yeah, there are a few still. But Gmail did really flip things on their head, which is, okay, this email is actually expensive if you want to have more than 5 megabytes in your mail spool if you're using a web email address.
Right.
And Gmail's like, you get a gigabyte, and it's always going to be free. Most people don't pay for their Gmail. I do right now because I just have such a ridiculous amount of junk in there. But it's not very much, and that is something that is possible across the board, right? With even things like a very heavyweight piece of infrastructure, which is the relational database.
Yeah, providing transactions, which is the mission critical systems behind lots of stuff. So cool. Well, thank you, Spencer. Did you enjoy this? Our ferns are still alive. We haven't out-talked anything, so.
We could though, I think.
I think so. So cool. Well, thank you very much. That was fantastic. Thank you everybody for joining us. Again, the recording will be made available. We'll send it out to everybody. We'll post it on our website and everything. So thanks for joining us. There is a survey that I believe should pop up when the webinar is over. If you could please take that. This is a new kind of forum for us to do this. So the feedback would be really, really fantastic to make sure this is right or not. So thank you, everybody. Thank you, Spencer.
You're welcome. It's great to join.
All right. And have a great day, everybody.